Alright, so in this video we will be going over Laplace transforms. Now what is a Laplace transform? Well, a Laplace transform is essentially taking a function with a real variable of t and moving it to a more complex variable s. And there's two ways to do this. You can do it using a chart full of Laplace transforms, which is the way we'll primarily do it in this section. Or you can do it using the definition of a Laplace transform. We'll do it using the Laplace transform definition first. So the Laplace transform definition is essentially saying you take the integral from 0 to infinity of e to the negative st f of t dt. Alright, so in our example here, we're going to have e to the negative t sine 2t. Alright, so first thing we want to do is we want to multiply e to the negative st by our function. And our function here is just e to the negative t sine 2t. And I guess I'll label this as an example. Now this isn't on the homework, but this is just kind of getting a feel for where these functions are coming from, because we'll be doing it a lot in this chapter. So anyways, we have infinity to 0 e to the negative st times e to the negative t sine 2t dt. Alright. Well, when we multiply exponential terms, we just add the exponents. So we're going to have 0 to infinity. E to the negative, I'm going to factor out a negative t, so we end up with s plus 1. And then if we were to factor that back, we'd with negative st minus t. So we can do that. Sine 2t dt. Alright, so to solve this, you'd have to use integration by parts, but in our case, I'm just going to use the integral table in the back of the book, and this works itself out to 0 to infinity e to the negative t s plus 1. And again, this is just using the integral table in the back of the book, but we're going to get s plus 1 sine 2t minus 2 cosine 2t over s squared plus 2s plus 5. So now we have to evaluate that integral, or this integral rather, and to evaluate an integral that goes to infinity, we just do 0 to n, and we take the limit as n approaches infinity. Let me write that a little bit clearer. We have infinity 0, n rather. So we replace the infinity with n, and we take the limit as n approaches infinity. Alright, so let's plug in n. So we get e to the negative n s plus 1 times s plus 1 sine 2t minus 2 cosine 2t over s squared plus 2s plus 5. And now, remember, we have to subtract the bottom term. Well, e to the t, or e to the 0, is just 1. So we have 1 times t here is going to equal 0, so 0. T here is going to equal 1, so negative 2 over s squared plus 2s plus 5. And now we are left with e to the negative n s plus 1 times this, minus 1 times negative 2 over s squared plus 2s plus 5. Well, the limit as n approaches infinity is 0, and 0 times any function is 0. So this whole thing will turn to 0. Because, again, the limit as n approaches infinity of e to the negative n is 0. And you'll see this a lot with these types of problems. So that's a property you should be used to, and if not, get used to it, because you'll see it often. But once again, so we're just going to be left with this term, so we're going to end up with 2 over s squared plus 2s plus 5. And that's going to be the answer to this. And as you can see, this is a pretty long and roundabout way to solve this. So I think we should go over a little bit of an easier way to solve these problems. So an easier way to solve this would be to use a chart. So here is my chart. As you can see, you'll have it's in the second page of the packet we were given. Or you could find one of these online. But it's just a series of functions with t as its variable, and it gives the equivalent Laplace transform. So let's go over the two from the homework. So this is the equivalent as number 1 in the homework. We get 7e to the 9t, or negative 9t, sorry, minus t to the 4th, plus 5t, minus 2. Okay, well, we can take the Laplace transform of each term individually because we're adding or subtracting them. There's nothing being multiplied. So the Laplace transform of this is the same as the second one down on our formula sheet. It's e to the negative alpha t, or we don't have to really write that. But the Laplace transform of this is going to be 1 over s minus alpha. So we get 7 times 1 minus, or 1 over s double negative, because that's a negative and we're subtracting alpha, turns to positive, so it's plus 9. So 1 over s plus 9 minus, now we do this term. Well, this is the same as t to the n, the third one down on our sheet. It's n factorial. Well, here n is just 4 because it's the exponent associated with t. So 4 times 3 times 2 times 1 is 24 over, and the bottom is s to the n plus 1. Since n is 4, s will be to the 5th power. Okay, now let's do this term. We have 5 multiplied by the Laplace transform of t. Well, n is 1 because it's t to the first power. So we have 1 factorial, which is just 1, over n plus 1. Since n is 1, it's going to be s squared. And now finally, the first property on our sheet is a constant. And since it's a constant, we're just going to be left with minus 2 over s. So obviously a lot easier than using what the definition like we did in the last problem. And the reason is because we just can copy and manipulate the equation rather into a form that's in the chart and go from there. So let's do one more. This is the equivalent to number 2 in the homework. So this just has 2 terms, so number 2. 2t to the 3rd e to the negative 4t, minus e to the 8t cosine root 5t. Okay, so here let's bring up the chart again, and as you can see, 2t cubed e to the negative 4t is the same as t to the n times e to the alpha t, where our n is equal to 3 and our alpha is equal to negative 4. So we can take this 2 in front multiplied by the Laplace transform of t cubed e to the negative 4t. Well, like I said, our n is 3, so we have 3 times 2 times 1, which is just 6, over s minus alpha, so s double negative makes it a plus 4, squared, or sorry, to the 4th because n is 3. And what here? And that's it for that one. So let's move on to this term. And we have e to the alpha t, so alpha is equal to 8, and beta is equal to root 5, because root 5 is the coefficient in front of the t in the cosine term. So we have an e to the alpha t minus cosine beta t, so we just plug it into the formula. So s minus 8, this is the last one on our formula sheet, s minus 8 squared plus 5, because the root of 5 squared is just 5. And that's going to be it, so we can distribute that 2, and we get s plus 4 to the 4th in the denominator, minus s minus 8 over s minus 8 squared plus 5. And this is going to be the final answer. And as you can see in this section, it's pretty much just working with formulas and trying to get used to using that definition of a limit. So in the next section, we will be using properties of Laplace transforms to manipulate them into forms that we can just use these formulas to. So this is kind of the backbone to the chapter, so it's really important you understand this, and we'll move on to the next section in the next video.